Section 7.1, the inverse sine, cosine, and tangent functions. So I want you to recall that for a function to have an inverse, that the function must be 1-to-1. 1-to-1 means that the function will pass the horizontal line test. So, but wait, sine, cosine, and tangent are definitely not 1-to-1. I have the sine function graphed right here. In fact, since all these functions are periodic, any output value that we choose, anywhere between -1 and 1, will have infinite x out values that correspond, right? Definitely doesn't pass the horizontal line test. So why is this section called this? Well, trig functions are so important to science and math that we need them to have inverses. We need to be able to find angles that give us certain measurements. So we can impose restrictions on the trig functions that make them 1-to-1. So we change the domain and we can make it 1-to-1. All right, so if we restrict the sine's domain to, let me get a different color here. No, not blue, because the grid is blue. How about purple? I like purple. If we take and look at just a chunk of the sine function, right, that's here between, and remember what these x values are. This is -π/2 to +π/2. If I just consider that chunk of the function, now I can say, and think of that as a new function. Now that is 1-to-1. It does pass the horizontal line test, doesn't it? Right? I'm only looking at this section of sine. Right? So we're looking between -π/2 to π/2, including. Yeah? It will then, since now it's 1-to-1, it will have an inverse, but only on this domain. Sine only has an inverse from -π/2 to π/2 on its domain. All right, so we're going to write all this stuff down in just a second, really specifically. But I want you to recall something that if y is equal to f of x, right, the inverse of f of y will bring us back to x, right? Also, let's remind ourselves that the domain of a function is equal to the range of its inverse, and vice versa, the range of the function is equal to the domain of its inverse. These are going to be really important ideas going forward. All right? All right, so let's define the inverse sine function. Okay. The inverse sine function is just the function that takes that takes angle measurements back to the angles that produced them, right? So it takes sine measurements, sine values, and maps them back to the angles that have those sine values. All right? We write it in this way. We say sine inverse of x, or inverse sine. Notice this is just like taking, instead of sine, it's just like saying, often there's a parentheses, but not always, replacing f inverse with sine inverse, right? But we have to be careful about restricting the domain, because we can't define an inverse function to sine everywhere on the domain of sines. Okay? Well, we're going to say that the domain of sine inverse is again going to be the range of sine, right? Remember, so this is the domain of sine inverse equaling the range of sine, right? Looking back at our graph, sine values only go between -1 and 1, right? That's the entire range. And so that's the domain of our inverse. And the range is going to be restricted to between pi over 2, negative pi over 2 in pi over 2. This, of course, is the range of sine inverse that we are defining, but it's equal to the domain of sine on which sine has an inverse, right? It's a restricted domain. Yeah. Now, it's somewhat arbitrary, right? We could have picked a lot of different chunks, but this is the one that it's closest to the origin. It includes the origin, and I think that's why it's chosen. And it's always this, right? So you can't pick a different part of the sine function and define an inverse, and sine inverse won't be defined for that chunk. You could create a new function, of course, if you'd like, and call it something else, but it won't be inverse sine. Okay? All right. We know that also that if y is sine inverse of x, that's the same thing as saying sine of y equals x, right? So it's, again, it's the inverse function. It takes the y, it takes the values that are sine values back to the angle that they came from. Okay, really quickly, I just want to make sure that you don't confuse don't confuse sine inverse of x with sine of x to the negative first power, right? This is the inverse function of sine. This here, sine x to the negative 1 power, is the same thing as 1 over sine x, right? These two things are not the same. You do not find the inverse of sine by taking 1 over sine, right? Because remember, you're looking for the angle that gave you a specific sine value, and that's not necessarily 1 over the value, right? Okay, this is, I do have to tell you, the reason a lot of students make this error thinking that these two things are the same, and that's because, right, it is true that sine squared x is the same thing as sine x squared, right? So it seems logical. Oh my goodness. Sorry about that. It seems logical that if you see, like right here, if you see an exponent right between the sine and the x, you could move it out. But it turns out that that's only true for positive exponents like 2, 3, 4, not with a negative 1. Yeah, it works for everything else. Okay, and I'm not responsible for that. It's just how it's been done for years and years and years. I do agree, though, that's a little bit sloppy notation. I think what happened is when people wanted to square or cube the sine x function, or all the trig functions, they got lazy and didn't want to keep putting the parentheses there. That's what I think. Anyway, but it's just my thought. But anyway, so just be aware that those mistakes are made, and I don't want you to fall down that hole. All right, let's look at an example where we're asked to find the exact value of inverse sine, oh my gosh, I'm having issues today, of square root of 2 over 2. Okay, all right. So first, before we do this, let's just think about, what are they asking us, right? All right, inverse sine of the square root of 2 over 2 is an angle. It's the angle in a specific interval, in the interval negative pi over 2 to pi over 2, including both, right, whose sine value is square root of 2 over 2, right? Remember, we had to restrict the domain for sine in order to even define sine inverse, okay? So that's why we have to look for an angle, right? Because the angle is what we'll take the sine value of, and so that angle, what we're looking for, has to be in between negative pi over 2 and pi over 2, all right? Well, we can call on our old friend, the unit circle. Yeah? And we say, okay, we know 0's here. Now, where's negative pi over 2 to pi over 2? Oh, well, down here, right, is negative pi over 2, and right here is pi over 2. Right? So when we're looking at sine inverse, we're thinking about sine values, angles that all lie between negative pi over 2 and pi over 2. All right, so which angle in this interval has sine value square root of 2 over 2? Right? Well, it turns out, right, our friend pi over 4, right, whose x and y coordinates are square root of 2 over 2 and square root of 2 over 2, right? Remember the y value is the sine of pi over 4, okay? All right, so, and there's only one, right? There's only one angle in this interval from negative pi over 2 to pi over 2 that has square root of 2 over 2 as a sign, right? If we went into the fourth quadrant, that would be negative, okay? All right, so we say pi over 4 has sine value square root of 2 over 2, and pi over 4 is in the right interval, right? There are lots and lots of other angles in the world that have sine value square root of 2 over 2, right? Because there's an infinite number of angles that are coterminal with pi over 4. But we only want the one that's in between negative pi over 2 and pi over 2. So to answer our question, we say that sine inverse of square root of 2 over 2 is equal to pi over 4, right? Because pi over 4 is the angle that if we plugged into the sine function, the angle in that interval from negative pi over 2 to pi over 2, that if we plugged into sine would give us the square root of 2 over 2. All right? Now, what if you're asked instead about sine inverse? Actually, I want to leave my unit circle here. Let's find sine inverse of negative square root of 2 over 2. Yeah. All right. You might say, oh, well, I know that right here there's an angle, right, that has x coordinate square root of 2 over 2 and y coordinate negative square root of 2 over 2, right? So this angle must be the answer. It's 7 pi over 4. Well, you would be wrong. So we're going to say it's not 7 pi over 4. Why not? Well, because 7 pi over 4 is not in the interval. It is not in negative pi over 2 to pi over 2. And you might say, well, yeah, it is. But remember that this angle here that we've drawn, it has a different name. It is negative pi over 4, right? That one is in the interval, right? So we would have to say then that sine inverse of negative square root of 2 over 2 is equal to negative pi over 4, since negative pi over 4 is also in between negative pi over 2 and pi over 2, right? Because remember, negative pi over 4 and 7 pi over 4, they're not the same angle. They're just coterminal with each other, right? And so since 7 pi over 4 does not, what's the value of 7 pi over 4? Well, pi is 3.14 times 7, you're looking at 21 something, 22 something, divided by 4. That's a lot different than just pi, 3.14 divided by 4, and negative, right? Those are two totally different values, two totally different angle measurements.